So here's one more example that shows how we can use what we're learning about quadratic equations to also apply it to financial situations. So when you invest money, your money grows exponentially. So this is really an example of an exponential equation, but a neat application to modeling. When you invest money, your money grows exponentially. So if you graduate from Penn State Shenango at the end of this semester and you start investing money, say you put $1,000 aside in an account that earns interest, maybe 5-6% annually. If you leave that money alone over time, after many years, that money can really increase in value. Initially, the amount that it increases is gradual. But over time, if you leave it there long enough, you're going to find that the amount that it increases is really going to start to take off. And so one equation that can be used to model exponential growth in this situation is the one that's represented here, but I see that the formatting didn't come through correctly. That should be to the t power. So this is an example where you're investing P dollars at a rate of interest equal to R compounded annually. That means you're earning interest every year, and your T is the amount of time that you leave that money in that investment account. So let's use that formula and see if we can go about determining an application to the business world. So suppose that $3,000 is invested. Well, we said that the amount invested is going to be our P, and that it's invested at a certain rate of interest compounded annually for 3 years. So that certain rate of interest not given to us is our R, but the annually for 3 years, that gives us our time. So we have time is equal to 3. We have R is what we're trying to find. We have P is equal to the initial investment. And we want to determine if after 3 years the value of the investment is $3,450, what was the rate of interest? So in our formula that we just discussed, the value of the investment after time t is the A. So A, in this case, is $3,450. So let's plug in everything we know. A is $3,450. P is $3,000. We don't know R, but want to find it. And T is 3. So what we need to do is solve for R, which is clearly inside the parentheses. So we know that when we're solving an equation for a variable, we reverse the order in which we undo operations. So instead of doing please excuse my dear Aunt Sandley, we do someone at Domino's made excellent pizza. So any addition or subtraction not in parentheses is undone first. We have none. Any division or multiplication not in parentheses is undone next. So we see our parentheses are being multiplied by 3,000. We undo that multiplication with division. That gets rid of our 3,000. Then any exponents get undone next. Well, if something is being cubed, then what you can do is cube root it to undo that cubing. So I divided 3,450 by 3,000 and got 1.15. And now I need to cube root to get rid of that cubing. When I cube root 1.15, it comes about equal to 1.0477. That's what 1 plus R is equal to. So to get rid of the 1 plus, then we have to subtract 1 from both sides. So we find that R is equal to 0.0477. So if I express that as a percent, must be the amount invested was invested at a rate of 4.77% annually.